Understanding Job Requirements. Welcome learners to the fourth module of this course. At the end of this module, you will be able to Number 1. Know about limits, fits and tolerances. Number 2. Know about engineering drawing. Number 3. Discuss about use of measuring instruments. Number 4. Discuss about tools used. We will take it one by one. But before we begin, here's a small activity for you. In this activity, you will learn to name the 5 tools that will show up on your screen. Number 1. Hammer. Number 2. Screwdriver. Number 3. Spanner. Number 4. Pliers. Number 5. Clamp. We hope that you were able to guess them correctly. Participants, let us begin our module by learning about basic deviation, tolerance and tolerance grades, and also understand what is transition fit, limits, and system for limits and fits.
System. In this video, we are going to see about shaft basis system. In this system, the different types of fits are obtained by associating holes of varying limit dimensions with a single shaft whose upper deviation is 0. Consider a clearance hole. Basic shaft, clearance fit, basic size, clearance, 0 line, tolerance zone of hole, tolerance zone of shaft. When the upper deviation of the shaft is 0, the maximum limit of the shaft will be equal to its basic size, which is taken as the base for computing all other limit dimensions. The limit dimensions on the hole and the shaft are computed by selecting suitable clearances and tolerances on the shaft and the hole. Interference fit, interference hole, basic shaft, forces required to insert the shaft, basic size, 0 line, interference or negative clearance, tolerance zone of shaft, tolerance zone of hole.
That was all about limits, fits and tolerances. Now let us check your understanding with the help of a small test. Question 1. What is a clearance fit? The correct answer is A. Question 2. What is transition fit? The correct answer is B. Question 3. What is interference fit? Correct answer is C. This is an important unit where you will learn the basics of engineering drawing, orthographic projection views, concept of quadrants, engineering standards, and the tools you require for engineering drawing. So starting with the basics, an engineering drawing is the subcategory of technical drawings. The purpose is to convey all the information necessary for manufacturing a product or a part. As engineering drawing uses a standardized language and symbols, it makes it easy to understand the drawings with little to no personal interpretation possibilities. In the welding industry, the best presentation method to communicate technical information through engineering drawing is through orthographic views, OV. It is because orthographic view records the exact shape of objects and is the best way to representing a 3D object in 2 dimensions. Talking about the orthographic projection in detail, it can be regarded as establishment of technical and machine drawings. Orthographic projection shows the object in its actual shape and size from the front, back, top, base, left or right in the first angle or third angle projection. When you arrange all the views, you place it as it would represent the object. Like the front view is taken as a base view, then the right side view will be on the right side of the front view, while the top view is placed over the front. In this way, it becomes easy to envision the object in its actual form. Principal plane lines are known as cross 90 degrees development lines that isolate the zone in which drawings are divided. These lines are like coordinate system and are not shown in the completed drawings. To understand how to draw these views, first we need to understand the planes of projection and concept of quadrants. You can understand the 4 quadrants as: first quadrant is above horizontal plane, that is HP, and in front of the vertical plane, that is VP. Second quadrant is above the HP and behind VP. Third quadrant is below HP and below VP. Fourth quadrant is below HP and in front of VP. If the projection is in its first quadrant, it is the first angle projection. If it is in the second quadrant, it is the second angle projection. If we imagine the projection in the third quadrant, it is a third angle projection. And in the fourth quadrant means it's a fourth angle projection. In orthographic projection, we use 2 types of projections. The first angle projection, also known as the European projection, and the third angle projection or the American projection. They both look almost the same except for their relative positions on the drawing paper. To do the drawing effectively, you can keep certain tips in mind. Visualize the object in your mind. Determine views and size to show the object clearly and on the correct scale. Always locate the inside lines of the object. Take one edge as a reference to assess the proportionate length of alternate edges. Show complete detail by filling the points of interest to the right extent. Use measurement arrowheads and lines and fill the correct measurements. Embed the title and notes on the sheet and do the final check upon completion. Once you know the basic tips, you need to adhere to some standards for drawing to make your drawing easy to understand across a region. Now you can see the different sheet sizes for drawing. From A0 to A5, you have all the details on the screen. Next up is various types of lines and line styles. Visible lines are used to represent edges. Hidden lines are used to represent edges which are not visible directly. Center lines represent the axis of circular features that are long and dashed. Cutting planes are thin and medium dashed lines that define sections of section views. Sections are thin lines that represent section upon cutting of an object. Phantom lines indicate the feature or component of the assembly, which is not the described part or assembly. After that, we have dimensioning to demonstrate the appropriate sizes of features. They are of 2 types: linear dimensioning and ordinate dimensioning. Linear dimensioning, where the two parallel lines, also known as extension lines, separate at the distance between two components, which are shown at every element. A line perpendicular to the extension lines, known as the dimension line, appears between the ending at the extension lines. The distance is shown in numerical form at the midpoint of the dimension line. Ordinate dimensioning. Measures along the x and y axes are shown by these extension lines, with the distance written in numerical form at the end of these lines. That was all about engineering drawing. Now let's move to tools. Participants, in the unit we will talk about tools, and after its completion, you will have knowledge about different hand tools and how to use them properly. We will begin with spanners. Made with high tensile alloy steel, it is used for tightening or releasing a nut, bolt, or threaded fasteners. The tool has jaws and openings at both ends to fit into hexagonal or square nuts and bolts. There are various types of spanners. Let's explore them one by one. Open-end spanners are open at both ends. Socket spanners are cylindrical shaped and have a square opening at one end and nut or bolt head opening at the other. The nut or bolt head opening can be a single hex socket or a double hex socket. Ring spanners have a ring to apply greater force for removing difficult or frozen nuts. Combination of ring and open-end spanners have ring opening on one side to open the nut and open-end opening to tighten the nut. Adjustable spanners are open-end spanners with a movable jaw and are suitable for heavy service. However, they are not recommended in the metal industry. Reversible ratchet spanners are used simultaneously with sockets and a wide range of socket accessories as they speed up the turning motion when tightening or loosening the nut. Next we have mallets, which can be called as soft face hammers and are used on soft metals like lead, copper, aluminium to prevent stretching of the material. They are of following types. Rubber mallets have a cylindrical head made from a solid rubber attached to a wooden handle. Next we have plastic mallets and copper and rawhide face mallets with cast steel heads where screws can be inserted in. After mallets, we have pliers. Pliers are used in gripping tools for components that are difficult to hold or grasp. Different types of pliers are as follows. Combination pliers have flat jaws and pipe grip, serrated for general gripping and holding. Pipe gripping section is to hold cylindrical objects, while side cutting jaws are used for cutting soft wires like copper wires. You use the combination pliers as shown in the image on your screen. Slip joint pliers are multi-grip pliers having a shape pivot pin to fit into two or more openings in the legs, due to which they get a range of jaw openings for parallel gripping in a number of positions. They are useful for holding and controlling small components and bending light gauge sheet metal parts. Diagonal cutting pliers is also known as side cutters, made with jaws cranked or offset like they are set up on an angle so the wires are cut close to the surface or in confined spaces. They have insulated handles for electrical work. However, it is advisable to ensure the power is disconnected first before cutting electrical wires. Circlip pliers is also known as C-clip, Seeger ring, snap ring or Jesus clip. It is a type of fastener or retaining ring consisting of a semi-flexible metal ring with open ends which can be snapped into place into a machine groove on a dowel pin or other part to permit rotation but to prevent lateral movement. There are two basic types, internal and external circlip pliers. Now we have clamps that are common to metal workshops. Clamps find a variety of use in situations which require holding or aligning of materials during welding, riveting or screwing. Types of clamps. G-clamps or C-clamps are forged from high-quality steel and are used by means of turning the screw through the bottom of the frame until the desired state of pressure or release is reached. In the case that the clamp is being tightened, this is when the objects being secured are satisfactorily secured between the flat end of the screw and the flat end of the frame. If the clamp is being loosened, this is when a sufficient amount of force is released to allow the secured objects to be moved. Now we have screwdrivers. They are one of the most common used tools, with a blade fitted to a handle to tighten or loosen the screw. They are easy to use and its handle is insulated with plastic. Moving on to the next tool, that is file. They are one of the most important and most frequently used on the fitter's hand tools. They have a range of application for roughing and finishing surfaces, shaping small parts and reducing the size of one part to fit into another. Here you can see different parts of a file on your screen. Now learning about its classification, files are classified as follows: hand file, flat file, half round file, round file, square file, 3-square file, needle file, triangular file, knife file. Here you can see how to use a file. The last tool we have is torque wrench, which is used to apply torque to a fastener like a nut or a bolt. It is used where tightness of bolts and screws is critical. With this, we have learned about all different hand tools that you would have to be used at the workplace. Now let us check your understanding with the help of a small test. Question 1. In the metal industry, what are adjustable spanners used for? Correct answer is C. Question 2. In the metal industry, what are mallets used for? Correct answer is D. Question 3. In the metal industry, what are the slip joint pliers used for? Correct answer is A. In this session, we will learn about the different measuring instruments and how to use them properly. By the end of this session, you will be able to identify different measuring instruments and their proper use. Measurement is the comparison of one quantity with standard quantity. Any measurement can be judged by the following values: level of measurement, which includes magnitude, dimensions, units, and uncertainty. Measurements are most commonly made in SI system, which contains fundamental units like kilogram, meter, candles, second, ampere, liter, and mole. Next we have unit of measurement, which is a definite magnitude of a physical quantity, for example, length, mass, and time. There are three systems of measurement: CGS, FPS, MKS. But nowadays we use the SI system, which is the standard system of measurement. It has 7 fundamental units and 2 supplementary units. You can see them on your screen now. Now we will learn about measuring instruments. Measuring instrument is any gadget which you can use for measuring a physical amount. They are classified into 2 types. precision instruments, which measure with an accuracy of 0.01 mm or more, like Vernier Calipers, Micrometer, etc. And non-precision instruments, which are used for measurement of parts to a visible line graduation, for example, seal rule. For precision instruments, you should know an important term, least count. Least count of an instrument refers to the smallest amount that can be measured precisely by the instrument. It shows the level of precision and accuracy. Now let us explore different measuring instruments. First is seal rule. It is a flat and thin linear measurement instrument and one of the most commonly used. It is made of stainless steel and is available in different sizes like 150 mm, 300 mm and 600 mm. Usually the reading accuracy is around 0.5 mm. Different types of rules available are ingenious rule, folding rule, flexible rule, hook rule. After seal rule, we will now learn about Vernier Calipers. It is a precision measuring instrument which is used to measure inside and outside diameter of shaft, and thickness of parts have accuracy of 0.02 mm. Vernier calipers measure reading of distance directly with precision and high accuracy. Now let us understand the different parts of Vernier calipers. Number 1. Outside jaw, to measure outer diameter and width of an object. Number 2. Inside jaw, to measure inner diameter. Number 3. Depth probe, to measure depth of an object. Number 4. Main scale, scale set apart in millimeter. Number 5. Main scale, scale set apart in inches. Number 6. Vernier scale, interpolated estimation in millimeter. Number 7. Vernier scale, interpolated estimations in inches. Number 8. Retainer, used to lock movable parts. After learning about parts, we will now see how to calculate the least count of Vernier calipers. Once you use Vernier calipers to measure reading, you will get a better idea. After Vernier calipers, it is time to explore the micrometer. A micrometer is a gadget assimilating an aligned screw broadly utilized for the exact estimation of segment in mechanical trades and machining. They are used to measure very small distances. Now let us check the different parts of micrometer. Frame, the C-form part that clasps the anvil and barrel in steady connection to each other. It is thick since it needs to limit flexion, magnification and compression, which can misinterpret the estimation. Anvil, the gleaming part that the spindle pushes toward and that model leans against. Sleeve or barrel or stock, the stationary cylindrical part with the straight scale on it. Lock nut or lock ring or thimble lock, the rough part or lever that one can fix to hold the spindle stagnant, for example, when instantly holding a measurement. Screw it is the main part of the instrument, stays inside the barrel. Spindle, the gleaming round part which pushes the thimble towards anvil. Thimble, this part turns by the thumb. Ratchet stop, applied pressure can be limited by the device in the end of the handle by slipping at an aligned torque. Here is how you can calculate least count of micrometer screw gauge. After micrometer, you have a height gauge. A digital height gauge is a precision measuring device used specifically for measuring height of 2 points. It has a precision of up to 0.0254 mm and claims consistency of plus minus 0.00254 mm. Now you will learn about the feeler gauge. A feeler gauge is a measuring tool used to measure gap widths. They are used to measure the clearance between the two parts. They are made of a number of small steel strips of different thickness with measurements marked on each piece. After the feeler gauge, we have dial indicators. Dial indicators are also called dial gauge and are used to measure smaller linear distances. Its typical measurement range is 0.25 mm to 300 mm. Now we have spirit level, which is used to level machines. You can check horizontal levels by placing the spirit level in the center of the surface or object correctly. If the air bubble will sit between the two lines of scales, then the surface or object is level. If the bubble sits on the left side of the lines, this means the surface or object is at high from left side and vice versa for opposite side. You can check vertical levels by positioning the rear edge of spirit level against the surface or object. Lastly, we have water level, which is used for matching elevations of locations which are too far. After learning about different measuring instruments, you should learn about calibration of measuring instruments. Instrument calibration is one of the primary processes used to maintain instrument accuracy. Calibration is the process of configuring an instrument to provide a result for a sample within an acceptable range. Eliminating or minimizing factors that cause inaccurate measurements is a fundamental aspect of instrumentation design. It is important to calibrate measuring instruments because the accuracy of all measuring devices degrade over time. This is typically caused by normal wear and tear. However, changes in accuracy can also be caused by electric or mechanical shock or a hazardous manufacturing environment, example oils, metal chips, etc. Depending on the type of instrument and the environment in which it is being used, it may degrade very quickly or over a long period of time. The bottom line is that calibration improves the accuracy of the measuring device. Accurate measuring devices improve product quality. That was all about measuring instruments. Now let's proceed to diagnosis of defects. Now let us check your understanding with the help of a small test. Question 1. Which of these rules is not used in the metal industry? Correct answer is C. Question 2. On a micrometer, what is the spindle? Correct answer is B. Question 3. On Vernier Calipers, what is the accuracy achievable? Correct answer is D. Welcome to the last unit of this module. At the end of this, you will be able to identify defects in tools. To detect defects in tools, management must establish a system to check the condition of tools on a regular basis. Whenever you come across a damaged tool that is not repairable, you should discard it immediately. Few problems you must be aware of are: also, before using hand tools, do the following. Double check all tools before using. Never use a defective tool and make sure that all defective tools are repaired before using. Always check the following problems to ensure effective usage of tools. Unoperative guards. The on-off switch is not working properly. Insufficient grounding of power tools. No ground wire on plug or in tools. Wrong grinder wheel. Cracked blade of tool. Wedged back the guard on power saw. And with this, we end this module. Next up is an activity and a test for you. In this activity, you are presented with different nuts and bolts, and you have to tell which is the right tool to use. The candidates must look at the images and submit their answers. First, nut and bolt will be the ring of spanner. Second will be of open end spanner. Third will be of screwdriver. After this activity, you just have to take the final MCQ test to complete this module. Question 1. In the orthographic projection, projectors are parallel to each other, true or false? Question 2. Dash is a drawing instrument used by draughtsmen to draw horizontal lines. Question 3. Alternatively thick and short double dashed lines used to represent sections, name them. Question 4. Pencils are specified on the European system using H, F and B. What does G stand for? Question 5. Mention key differences between European projection and American projection. Question 6. Mention the formula to calculate least count of micrometer. Answer. You have successfully completed this module and you are ready to proceed to the next one. All the best.